Anderson-Darling test, or the test for normality. This test is used to check if your data follows a normal distribution or not. So please don't go anywhere else. Just sit back, relax, and enjoy this complete video. So before understanding Anderson-Darling test, let us understand what is normality. Normality refers to how closely your data follows a normal distribution. If your data follows a normal distribution, it will look like a nice bell-shaped curve where most values are in the center. Let's break it into simpler points. Most values cluster around the mean. That means your data is concentrated in the center. It is neither left or right. That is our next point. Distribution is symmetric. That means left side will always be same as your right side. Mean, median, and mode, they all will be same. So all the key averages will almost have same value. Now there are two approaches to check the normality. We'll talk about this like graphical method and the statistical method. Anderson-Darling test is named after two individuals, Anderson and Darling. These two individuals in 1952 created this Anderson-Darling test for normality to assess how much data set matches the normal distribution. Anderson-Darling test is a statistical test used to check if your data follows a specific distribution, and that is usually the normal distribution. In simple words, are your data points behaving like a bell curve or not? So Anderson-Darling, in comparison to other tests, focus more on the extreme values of tails, while other tests focus at the overall shape. This helps detect outliers and solve the real problems worldwide. It is very sensitive to outliers and deviations at the end. How to interpret your Anderson-Darling test results? Now think of it like you are checking if your data looks like a normal bell-shaped curve or not. So we have two methodologies. A-squared statistics test to check if your data follows the normal distribution. So A-squared tells us how far your data is from normal shape. If it is small, A-square value, and data is very close to normal, that is actually good. If A-square is big, data is very far from normal, and that is where the problem lies. The other methodology is which is most preferred is the p-value. This is what you should always focus on. So p-value tells you whether you can trust normality or not. So let's take the first case. If p-value is greater than 0.05, that means you fail to reject the null hypothesis. In this case, data is normal. So we don't find any problem here. Second case, if p-value is less than 0.05, that means we will reject the null hypothesis here. Data is not normal. There is something wrong with the data. Now think of it like higher the p-value, data is fine. If there is low p-value, there is something problem with the data. When to use this Anderson-Darling test? First case, before applying the statistical analysis. That means use it when your method assumes normal data like t-test, ANOVA, regression, control charts. Why? Because wrong assumptions can lead to wrong results. Second, doing the Six Sigma or the quality projects. You very common methods used in like DMAC methodology, especially in the analysis phase, process capability studies, CPK, PPK. Then examples like before calculating your CPK, check if the data is normal. That is where this is important here. Then after SPC or the control charts, first ensure that the process is stable. That is the primary requirement of statistical process controls. Then check if the data is normal. You can use the Anderson-Darling test here. This ensures that the data is reliable and valid as well. Next point is when the data looks suspicious, either it is skewed or you have outliers. So if histogram or a QQ plot looks like it is skewed or heavy-tailed, then use Anderson-Darling test to confirm them mathematically as well. So what to do if your data isn't normal right now? Just relax, I would say, isn't the end of the world. We will look at what you can do if your data isn't normal, and how to still run some meaningful statistical test. So when your data isn't normal, we have two options. First is to transform your data. That is basically reshaping your data to look more like normal. And what are the methods? So first method is the log transformation. So this works great when your data has long right tail, like income or reaction time. Taking the log compresses the large values and bring them closer to the rest. Next, we have the square root transformation. This is useful when you have count data, for example, the number of defects. It reduces the impact of large numbers. And last but not the least is the box-Cox transformation. This is a more flexible mathematical approach. It tests the different power transformations and find out the one that makes your data more normal. So after all these transformations, by applying any of this method, you will recheck your data with normality test or the QQ plot. If it is normal, then you have achieved your success. You can use any of the parametric test confidently now. But what if your data is still not normal? Then you have option 2. That means you need to now use some non-parametric methods to convert it. So these tests does not assume normality at all. They work with rank instead of actual values, making them perfect for skewed or the ordinal data. And what are the options that we have under non-parametric test? We have like Mann-Whitney U test, which is like a non-parametric alternative to independent t test. Next, we have the Kruskal-Walsh test, which replaces one-way ANOVA when your data isn't normal. So in the end, I would say just remember, if your data isn't normal, it is not the end of the world. You can either transform your data using any of the transformations or use the non-parametric test that doesn't require normality at all. So if you're watching this video on YouTube, don't forget to hit the subscribe button and do press that bell icon for all the notification from digital learning. And if you're watching this video on Instagram or Facebook, do follow us on all these platforms. You can also look at our website for interesting articles and videos. Link for all these is given below in the description. Now is the quiz time on this topic. Read the questions carefully and leave your answers in the comment section below. First question. What is the main purpose of Anderson-Darling test? First, to compare means between the two groups, to check if the data follows a specific distribution, to measure the correlation between the variables, to detect missing values. Question number 2. What does the p-value in Anderson-Darling test indicate? Sample size of the data, mean of the data, whether the data significantly deviates from normality, or the variance of the data set. Question number 3. If p-value is greater than 0.05 in the Anderson-Darling test, what does it mean? Data is not normal, data follows a normal distribution, data contains outliers, or the test is invalid. You can leave your answers in the comment section below.